Hi, my name is Chris, and this is my solution to number 31 of Chapter 2. The question says, if the input and output of a causal LTI system satisfies the difference equation y of n is equal to a times y of n minus 1 plus x of n, then the impulse response of the system must be h of n is equal to a to the nth times the step function. Part A asks, for what values of A is this system stable? Well, because this is a causal system, we know that we only need to look at values as n approaches infinity. So we want to figure out when h of n is absolutely summable. So h of n is absolutely summable when a is less than 1 for this sequence. If a is greater than 1, then h of n will diverge. Part B says, consider a causal LTI system for which the input and output are related by the difference equation y of n is equal to a times y of n minus 1 plus x of n minus a to the nth times x of n minus capital N. Determine and sketch the impulse response of this system. So for this problem, I skipped ahead to Chapter 3 and used the Z transform to find that h of z is equal to 1 minus a to the capital N times z to the minus n over 1 minus a times z to the minus 1. And this is really easy to take this Z transform because it's a finite length sequence. Looking at table 3.1 in chapter 3, this Z pairs with this h of n sequence, where a to the h of n is equal to a to the nth for n in between 0 and capital N minus 1, and it's 0 otherwise. The sketch of this function for if a is greater than 1, it'll look like this. As n goes to infinity, a will increase exponentially. And if a is less than 1, as n goes to infinity, the graph will approach 0. Part C asks, is if this system is an FIR or IIR system. I think it is an FIR system because h of n has a finite duration between 0 and capital N minus 1, and it's 0 otherwise. And part D asks, for what values of A is the system stable? In an FIR system, all values of A will make the system stable.